Hello and welcome to Intro to Multiplayer. This is the second part of a tutorial series I'm doing. You don't have to have watched the first one. The first one is a great amount of background info. I'm going to do a little bit of a quick recap at the start of this video to make sure people at least have a bit of an idea of some of the terminology before we get into what I call a walkthrough, where I've got an example project where I can hopefully demonstrate some of the things that we've been talking about in action and give you some more contextual examples to hopefully help you make more sense of this stuff. So first off, let's talk about multiplayer games. A quick recap. When you're making a game in Unreal, you're probably going to be looking at three different kind of multiplayer modes available to you. One would be standalone, which isn't typically multiplayer. You can do local co-op using that. It's just one game instance, one application booted up. Then we have our dedicated server kind of structure, and what you typically have with that is a special build of the game which will run as a dedicated server. It doesn't have a viewport, so you're not going to have any players playing on that. Think of it as just a console application, like a little black window with white text on it that just runs on a computer that is accessible on the internet or a network typically. And then you'll have other players who will launch a client, the kind of retail version of a game, that can then connect to that server so that they can join the same game. And in that situation, we need to synchronize the world between all players. So the server is going to be authoritative, which means they are the ones who know what the world should look like, and they send out updates to any connected clients saying, oh, this character's moved over there, or this person spawned an item over here. Okay, so that's our most common multiplayer setup, and that's what we're going to be talking about in our examples today. And then the final type is a listen server. We're not going to be really looking at those in the demo today, but how they work is one of the players acts as the server as well. So the server will have a viewport and have a player playing on it, but then other clients can join that person's game, and that typically suits smaller games and certain environments, but you can watch the other video to learn a little bit more about that as well. So with the dedicated, as I said, the main server is not going to have a viewport. It's just going to be like a console application almost running on a computer, and then clients will connect to it. Clients will have a local viewport, can give input to the game, and the way to think about it is like the clients will know about all of the levels and that. The server doesn't need to send every bit of data to it. Both server and client have all of the game files, but what happens is anything that changes during runtime, updates to those needs to be sent out to the various clients. And the way to think about this is, let's say that a character changes the clothing that they're wearing, they put on a hat. The server, just to make sure it's clear, if the server will need to tell the client, hey, player 2 has just put on a hat. But it doesn't need to send like the 3D model and the textures of that hat down to clients. That's not how the replication is working typically, because the client already knows what the hat looks like. It just needs to be told, oh, this character is now wearing a hat. And then the client can react to that, look up the game files, and put that hat on the player's head so it looks like that then. So keep that in mind. As much as like the server is authoritative, it doesn't mean that the server sends everything to the clients. The server is just the one who has authority over moving or changing things in the world, and it's responsible for telling all clients about that as well. So that's a general summary of it, and one thing that's important then is the player controller class. The player controller class gives players a means to communicate with the server, because when a player connects to a server via a client, they will be assigned a player controller, and a connection is made for that player controller. And this allows the server to send messages to the clients and vice versa in some situations as well. So yeah, the player controller therefore is an important class because it's our way to send messages to the server if we're a client. So there's a few concepts we're going to cover in this. Replication. That replication is a broad term that can cover a lot of things. When I'm talking about replication in this tutorial, we're talking mostly about the replication of properties. And what this means is I am sending an update of data about an actor to the clients. So a property or a member is sometimes called. So if you had a character that had health, we could make that health number be replicated, a replicated property, and that means when the server changes the health from 100 to 45, that it's then going to update that value on clients. It'll replicate out to them, and then the clients have that information. The other concept we're looking at is on reps or rep notifiers. That is a way for us to react to that data changing. So if we have that health example, the client, when they receive that update saying, oh, the character's now on 45 health, what you can do is you can say, whenever it changes, run this logic. And it might be things like, okay, get hold of my UI, send an update to the UI so the UI knows what health I'm on to, and then that can change color in the position of the expandable bar that's representing the health or whatever it be. You might also have a thing, if my health is under 20%, play the kind of red border around the screen to give that sense of danger that you're almost dead. So we could do that in an on-rep if we wanted to. It's a reaction to a replicated property changing. And then the third main concept we have is RPCs, a way to communicate between server and clients. And this, instead of just changing data, this is a way for us to tell either the server to tell the client to do something specific, or any connected client to do something specific, or the client can request for the server to do something as well. So we call a function that exists across the network. So examples of this would be, again, we could do the health changing via something like that, but let's say it's more of a when a player on the client shoots a gun, it's going to send an RPC to the server to say, hey, I've just tried shooting. Then the server would check, okay, is this a valid thing for them to do? Do they have ammo to do this? Then what it would do is work out who takes damage from that, and then it would share that with everyone else. And they might send a server to all clients RPC then, that's called a multicast that they would do, so that all connected clients will get that updated information if they are relevant. Now that relevancy term is the last thing that we want to recap. So relevancy is a term that encompasses whether or not in a multiplayer game, if we've got two clients connected to a server, just in for example now, there may be actors in the world that are replicated, and the server's responsible for keeping player 1 and player 2 up to date with that information. So let's say we've got a replicated actor in one part of the world and player 1 runs all the way across the other side of the map. It could be argued, therefore, that if the player gets so far away from this actor, they can't see it, they can't hear it, so why does the server need to send updates to this player about the actor that's really far away? So this concept of relevancy means we get to a way to decide rules of when does a player need to be sent updates about an actor? And this is mainly an optimization thing, so that we're not always sending all information to all clients at once, because if we did that, we would struggle with larger games, and especially games that have a larger amount of players playing at once. So relevancy is a way for us to control that, but also it's a powerful tool to control, maybe you want, if two players are on different teams, you want team 1, if they spawn a special team actor in the game, that you might not want player 2 to be able to see that, and you can use relevancy to kind of represent that too. You could say this is only relevant to players of the same team, and that way you can stop the other team seeing things they're not meant to see. So it's a tool for us to control what data should be replicated to which players. So that's a brief recap of the kind of theory side of things. And what I'd like to do now is to start going through a bit of a walkthrough for us to start thinking about a replicated game, start thinking about a multiplayer game and how it differs from a standalone game. So the very first example we've got here then, I've just got a very simple little level here. I've got some, we'll talk about this fake and real thing in a moment, don't worry so much about that. But what I've got is I've made a pawn. And in here, I didn't set up anything special on it. I just set them to have a mesh. And it inherits from default pawn, so this means it has a movement component on it. What that means is we get some movement out the box. If I press play, here we go, I can move around like so. Now, will this work out of the box in multiplayer? Now, I admit, when I was making this little test environment, I thought maybe it would. I didn't really think about it enough. And I was surprised when I changed it to simulate a multiplayer environment. And you can do that in editor. So let's do that now. So you can change it to say, hey, we want to play as a client, which inherently means in a multiplayer dedicated server environment. And you can choose how many players as well. So let's say 2 players. And what we'll have now is 2 windows pop up representing those simulated 2 game environments. That could be player 1 and player 2 in different parts of the country connecting to a server over the internet. So let's go ahead and press play. We'll see 2 windows pop up, and you can see that we've got 2 characters facing each other here. But let's try and move. And what we're seeing here is, yes, I can move around, but player 1's moving, player 2 has no idea that they're moving. I was like, oh, oh yeah, you don't get that for free. So you get a lot of cool features out of the box with Unreal Engine. It has a whole networking system for you, but that doesn't mean just everything's going to work in multiplayer by default. But it's quite straightforward if you use the tools they give you in order to set it up for multiplayer. So the reason it doesn't work is because this particular pawn hasn't been set up to be replicated. And there's a means for us to go ahead and do that. What's happening, if we think about what's happening right now when I'm moving around this character, is I'm on my local computer. Imagine player 1 and player 2 are in different countries even, right, on different PCs. So player 1 is putting input into the computer, which is making this client move around. But there's no way for the client 2 or player 2 or the server to know about that unless we tell them. And out of the box, a pawn doesn't do that for you for free. So if we want to communicate like a player side input to say, hey, I've clicked my mouse to try and shoot, it's on us then to think, well, how does the server get to know about that in a multiplayer game? Okay, so how could we communicate with the server then, based on the recap that we just done? Now, there's a few ways to get data from server to client, but in this case we need to get data from client to server, and the only way you're going to do that is via an RPC, the remote procedure calls. Now you can go from client to server this way, and that's generally what you'd need to do. Now we could go ahead and go into this and start putting up a bunch of logic in here saying, okay, so when we get an input of movement, we want to go ahead and send an RPC to the server to tell them that. But thankfully, the character class, instead of the pawn class, comes with a sophisticated movement component that handles this out of the box for you. So if I was instead to play... So with a character, it has on it, let's just open up the class so we can see. In here, we can see instead of just a movement component, we have a character movement component. And this comes with a lot of stuff out of the box, which makes your character kind of just work in multiplayer, and you don't actually have to think about it. And so let's just see how this looks in contrast. So you can see now that when I move my character around, I'm moving it on the left client, player 1, and player 2 is getting updates on the movement, and I'm getting that for free pretty much, which is great. Now, what we need to think about is what it does free for us. And under the hood, we're not going to dig into the code or anything, but what is happening is when I'm pressing input on player 1's computer, which could be in a house the other side of the country to player 2, that input needs to be processed by that application, but then it needs a way to tell the server about it. And the way we're going to do that, it would be typically with an RPC from client to server. So within the movement component, it handles that, but it also does a bunch of other great stuff, like we talked about in the other tutorial, where it's going to handle a lot of movement prediction for you. It's going to handle a lot of movement smoothing for you as well, so that you don't have players waiting for updates from the server and have the players kind of warping around the screen. So yeah, you get a lot of things out of the box for this. So since we're not going into the character movement itself, let's just see what we've got added onto the characters. So we've got these relevancy visualizers. So all I've done here is just drawn a debug sphere that matches the relevancy radius of these characters. So we're just using default relevancy rules for these. There's no override of what makes one character relevant to another. So what this means is it's just using the net cull distance. So I've set it to be quite a short radius here. So you can see the yellow ring around this player. If I was to move outside of this, if I was to move so the character in green is outside of this ring, and we give it a few seconds, what we'll see is that character will disappear off of our screen, like so. And that's something that happens when you go outside of relevancy. It takes a few seconds for the actor channel to get closed down, because keep in mind, we could be just like popping in and out, and you don't want the character to keep popping in and out each time you do it. So there's a little bit of time before it'll kind of say, okay, they've not come back into relevancy, let's sever this actor channel. And when the client has that actor channel closed, it destroys that actor. So then it doesn't exist on the client. Now what happens when we come back into relevancy is the server detects, okay, now the player needs to know about that other player, and it opens an actor channel, and the process of the client receiving that channel getting opened is then going to say, all right, we need to spawn this actor, and it is now back in this relevancy list where it's going to be getting updates from the server, and it can see what the other player is doing. Okay, so that's what these circles are. I've tried to do them in colour so you can see what they're for. So this blue one is going to be relevant the relevancy of this blue ball that's going up and down. And we're going to have a little look at these in just a little more detail shortly. So if you want to change the cull distance of a character or any actor, then we can go into the actor. So let's open up our character, for example. And what we want to look for is that culling. Let me click up here first. Is it not net culling? Here we go here. So net cull distance. So this value here is what you're using. Now it's a little bit confusing to look at if you haven't looked at this before because it's a huge number. Now it's because it's a squared number, and if it makes it easier for you to work with and you're used to using the Unreal units, so I think one Unreal unit is a centimeter, right? So if we want it to be 5 meters, that we're going to be looking at 500. So if you wanted to do that, what you could do is just type in 500 and then press star to do a multiply, and then 500 again, and it will square it for you then, so you don't have to do the calculations yourself. So even though we use the kind of less intuitive squared distance, you can just do the formula in the details panel here, and it'll fix that for you. Okay, so I think I ended up having mine a little larger than that. Let's just, I think it was 1200 by 1200 maybe, or it might be a little less than that. Yeah, I might have got it a bit larger, but it should hopefully look roughly the same anyway. So let's go in this and see. Now the circle will be a little bit larger. I have to walk a little bit further away before I go out of relevancy, but it's the same sort of concept that we're seeing. Now what we can do also is we can set the actor to be always relevant instead. So ticking this overrides the default relevancy rules here. So let's go into our relevancy section. It might be hard to find with all of this, so let's just type it in quickly. So here we go. So inside of the replication section, we can see that we've got this always relevant tick box. So if I tick this, that will override that distance rule. And now what we get is, if we're to play this, no matter how far away I go, these characters will stay in sync with one another, and they're not going to go out of relevancy. And so you're always going to get updates from them as a result. So that's the kind of basics now of just relevancy and how to handle relevancy. You can go into a lot more detail as we went over in the first video, but let's have a little look at some actor behavior and looking at how we can take this moving ball and handle the replication considerations for this. So let's open what I've named a fake replicated actor. It's not fake replicate, it's just not been set up for replication. And I just want to go through what this does. So this is a moving actor that continually travels up and down between a min height and a max height. We don't need to understand all of the logic in here, but effectively on our tick, it's going to call a function called try move actor. And if I go into this, it's got some little logic in here that makes it move up until it gets to a threshold, then it'll move down, and it'll continue that loop. There's also a little bit of logic in here where you can make it not move. There's a variable called should move, and I've set up some rule that if it collides with a pawn, it will stop moving for 5 seconds, and then it'll carry on. Okay, so it's very simple actor, but enough for us to kind of showcase what we need to do. So let's have a look how this works in multiplayer. Let's move this raptor to the side because we want to focus on this fake one, as I said. So does this work in multiplayer? That's what we want to look at to begin with. Well, it looks like it, right? We've kind of got the ball moving up and down here, right? But it's not replicated. All that's happening, you can see it's slightly out of sync. But if you think about what I said at the start of this, is that we have server and clients. The server has authority over the state of the game, but both server and client both have all of the game files. They know about all of the actors and the scripts and the models and all of the things that you're using in the game. They have those installed on that computer that's running the game. And so this moving ball is running on both clients and servers at the moment. It would all run the same logic here. So it looks like they're doing the same thing, but it's just because they're running the same code. It's not actually replicating it. It's just they're running the same code, so it kind of looks like they're doing it. So let's have a look what happens then if one of the characters moves into it. Remember I said if you collide with it, it should stop it. So I'm going to move into it. Let's move into it. Ah, it stopped. And it stopped on both of them. It looks like we've got a replicated actor. But again, we don't have a replicated actor. Why did that actually stop it then for both? And this is where we start thinking again about how game code is running on the different clients in the server. So what's happening here, if we just focus on this window here, okay, so this is player one. Player one has two pawns in their game world. They have this one that I'm controlling, and they have this one, the green one over here. So they both exist in the game. And then we have this fake actor as well. Now, just because when I move into it, we'd expect it to stop. But if you think if the second player was to then move into this, that second player has a representation via a replicated character on the first client. So when this green actor goes into it, the representation of that, the proxy of it on the client one, is also going into it. So it'll also collide with it. So actually what's happening here is the movement, the stopping of movement isn't replicated, but the fact the character's replicated means that the character will hit the ball on both player one and player two screen. And so that logic would run to stop it on both clients. So again, we're in a situation where it kind of looks like it's replicated behavior, but no, this is just the fact that the game code has some replicated actors and it can react to the data in the same way on two different game instances. So a way for us to demonstrate this not working then would be the following, because I said this only works because this player one has that green pawn which represents player two on their screen, right? But what happens if I move outside of relevancy of this then? So I'm going to move outside of relevancy of that. So the green pawn should now disappear. With this, oh, I think I left them as always relevant, didn't I? Apologies. Let's go back into this and turn off always relevant. We'll quickly do this again. So if I was to move out of relevancy of the green, they should disappear in just a short moment. There they are. And now what we're going to do is we'll walk into this ball as the green character. And what do we see? We see that it stopped for this because I've made that collision. The ball ran the code. Oh, its collision has happened. I'm going to stop. But on the other player, the pawn doesn't exist because it's been despawned. It's been destroyed because it's no longer relevant. And so there's nothing actually hitting that ball as far as this client is concerned. So what do we need? We need to actually make this replicated. It's interesting to think about some things that you can get to happen on all clients without replicating, though. To consider that you can get the same behavior happening on clients just by a reaction to other data getting replicated. So you sometimes need to weigh up what actually needs to be replicated. But we can solve this by making this a real replicated actor, so to speak, and that's where this blue ball over here comes into play. So I've got a little actor that I'm just going to subclass now. So if I just jump into my folder here, I've got a replicated actor base. So let's just make a child blueprint of this, like so. And what we see in here then is just add it up here. Not too much has changed about it so far, right? It's just the color of it has changed. In the event graph, we do nothing differently so far. So what we need to start asking ourselves then is, how do we make it replicated? It's pretty straightforward to start with. We just need to go into the replicated section over here, replication. And then we need to say, well, I want to make this replicated. So you tick this replicates box. So let's go ahead and do that. Let me go ahead and drop this one in so we can actually see how that one behaves. Because looking at the setup of this, it actually shouldn't be working. So let's go ahead and observe that, and then we'll talk about why. So again, we'll go out of range of it, and we'll get this character just to walk into it. I think we might need to just go a little further back, make sure we don't go into range of it. So I'm going to bump into this, and we can see it keeps moving on the other client still. So even though we flagged this as replicated now, this is still not actually syncing up. The reason for that, marking something as replicated doesn't mean this now just works in multiplayer. And that's for good reason, because we don't want to send everything out about every actor that we need to replicate something about. That would be a lot of data to constantly send out. There's plenty of things that are changing on the server that the client doesn't need to know about as well. So think of it that way. We need to manually tell this actor what needs to be sent out to other clients as well. So let's go ahead and let's go ahead and set up the movement to be replicated to. So you can see in here, we have a flag for replicate movement. So this is a nice convenience tick box which says anything to do with the kind of transform of the root component of this actor is going to be shared across the network as well. So shall we see if this one works as well then? So again, we'll get that situation set up where I move state in relevancy of the ball, but I get the green character to walk into it. And now does that stop it? No, it still doesn't. So why is this? Now, this is due to actually how I implemented the ball originally and gets us thinking about what code is running on client and what code is running on server. So we are replicating the movement, it is replicated, but it looks like it's not. So let's think about why that would be. If we go back into our base class, so this rect actor does derive from this fake replicated actor. So it inherits all of this movement code. And what we've got in this movement code, if you remember, if we go back into our main event graph, it's just called onTick, calls try to move actor, and then does all of its calculations and updates the actor location. Okay, so let's think that means that the actor on the server is running this code on tick, but also the actor on client 1 is running this code, and the actor on client 2 is running this code as well. So this code is running on server, client 1, client 2. There's nothing here to say, hey, this is a replicated actor. The actor should be controlled by the server authoritatively, and so we don't actually need the client to move it. We're going to let the server tell the client that it's moved instead. So that's where we can try and branch our logic based on what net mode that we currently, or our world is currently in. Now, we talked about net mode a lot more in the first video that I did, so if you're not familiar with these and you want a bit more of an in-depth information on it, you feel free to check out that video. But we can pretty much ask in these event graphs, or in C++, we can ask, what is our net mode? And it'll come back to you with dedicated server, client, or standalone. There is one for listen server as well. But they're the three that you really want to be thinking about in a typical dedicated server multiplayer environment, or if you're supporting standalone. So we can use that as a way for us to say, okay, we only want some of this logic to run on the server, and we don't want this to happen on clients, for example. So let us extend our class here so that we only call that function on the server. So because this class inherits from that one, I can just override the function. So let me go to override my try move actor. So this is still going to be called on tick. But what we're going to do here is I can just branch in here. I can say only do this if we are on the dedicated server. So I type in this dedicated and it comes up with is dedicated server. I can quickly branch the logic off of this. So let's plug these in. And now what we see is this is only going to run on the server now. And the clients aren't going to get that information. Sorry, let me rephrase that. The clients aren't going to run the code themselves. They're going to get that information from the server instead. So let's try and see whether this works any better now. Let's get out of range. We'll get the pawn now to move into this actor. Let's bump into it. And you can see that it's stopping on both of them now because the server is the one that's in control of that movement. Now, something we should consider at this point is, oh yeah, that looks great. But if you're supporting a game that can be both standalone, which is a single player experience where they don't need to connect via a URL to a server, and you're supporting multiplayer in the same executable, you need to start thinking about, well, will this work in standalone too? So let's quickly just have a little switch over, shall we, and say, all right, we want one player and we want this in standalone now, and see whether this works for us. So you can see now, this isn't moving. Why isn't it moving? Now, if we look at what we did in the code, we said if it's dedicated server, then move. Well, now we're playing in standalone, it isn't dedicated server. So that's where we think, well, okay, we could say, is it dedicated server or is standalone? And we could put this into an OR node if you wanted, and then you could feed this into your branch instead. But fortunately, we could use a simpler approach by using something called the has authority node. Now, we talked about this as well in the other video, where what has authority over a particular actor. Typically, the server will have authority over replicated actors. The client will have authority over actors that aren't replicated, that it locally spawns. It's not that common that happens, but there are situations where it does. And if you're playing in standalone, that standalone game instance will have authority over everything in the game as well. So to encapsulate this kind of sentiment, what we can do is just use the has authority. And what's nice about it is it has a little macro thing in here as well, which means we can actually skip the branch too. And now we can go ahead and say, well, if it's authority, which means if it's server, or if it's standalone, we do the logic. So let's go ahead and double check that this works, and we can see now this actor is moving in standalone. And if I update back to my multiplayer game, we'll also see that that blue actor is moving in our multiplayer game as well, which is good. So now we're going to have a little look at a bit of client input. Now we've had movement, which is client movement, which is client input. However, if you remember, I said a lot of this is handled by the character movement component, so we've not actually had to set up that client-to-server communication. We're going to give that a go now. We're going to handle that client-to-server communication, and we've got a very simple interaction implementation. So let's look how I set this up, just so you have a bit of an idea. So we have a bunch of things in the character here. The bit we care about here is an interaction input. So I've set up input. If I press E, it'll go ahead and check for the location in front of you, do a little box trace, see if it picks up anything that implements an interactable interface. And if it does, it checks if it can interact with it first. And if it can, then it goes ahead and interacts. Don't worry about this bit for now. So that's our logic that we've set up here. And then we have an interface, the one that interactable interface, super simple. It has two functions, can interact, which returns a bool, and then interact for us to define what we want to happen when you interact with something. And then we would implement that interface on any actors that we want. So you can see that this rect actor base child class ends up having this interface on it. And so we have the interface functions in here. So we have an interact, which we haven't defined yet. And then we have a can interact. So we're going to make sure that it can be interacted with to begin with. And then we need to think about what we want it to do when we do interact with it as well. So what we want to achieve here is there's a text renderer, which is this word above it that says rept. We're going to just set the text value of that when we interact with it. So let's start off and just implement that logic to begin with, right? And actually, if we have a look in the base class this all came from, the fake replicated actor, if we go into our interface functions in here, you can see that I've got a bit of logic already set up to show how we could do this. So when it interacts, first the can interact. If it's true, then it will allow us to go ahead with it. Great, nothing to think about there. And then what we do in here is we call a function called setName and pass a text in here saying client has interacted. And then a setName function, all it's doing is getting hold of this component and setting the text value to be that string that was passed in, or that text that was passed in, sorry. Okay, so it's quite straightforward. We can go ahead and demo this quickly, how it works. So if I walk up, let's do it on the screen that's facing him properly, and I press E, it says client has interacted, and you can see the trace box that I'm using. Same thing if we go up to this actor. Oh, okay, it's not happening. Now, it's not happening because we started overriding, if you remember, in this event graph, what happens when we interact. But let's get rid of that and let it use its base implementation, and let's have a think for a sec. Now, when I go up on this, even if I go up to this rect actor, so we expect it on here. If I change it on the non-replicated actor, we don't expect the other client, player one, to see that because it's not replicated. But if I go over to this and we think, oh, well, I'm setting a value on this, we can see that that's not also sent out to the other client. Well, why isn't it? There's a bunch of things to think about here, and we're really early in this process. We haven't done any setup for it. So this interaction of me interacting with it only happens on player 2, on their machine, on their instance of the game. The other players in the server have no way to know that that has happened. So what can we do about that? We can tell the server. And how do we go ahead and do that? Now, if you recall, the one way that the client has to communicate with the server, rather than the other way around, is via RPCs. So let's have a look at setting up an RPC so that when we interact with the ball, that it says, okay, on the server, I want you to stop, to change the name, sorry, above my head. So let's have a look how we'd go ahead and do that. So in our rep actor, we're going to now override the interact function. And what we want to do here is set up an RPC to say, okay, server, can you do this logic? So instead of just setting the name here like we did before, we want to tell the server to do it. So I'm going to make myself a function, an RPC function. We'll see how we do this now. So let me just call this server interact. Oh, sorry, I'm going to create the event first. So create a custom event. And then I'll just call it server underscore interact. And what we're doing then is when the client interacts, we say with it, we want it to then tell the server that it's being interacted with. So we can go ahead and do this. I'm then going to set this up to be an RPC. You do that by setting in the right hand side here where it says replicates. You can change it to be either a multicast, a run on server, or a run on owning client. Now we want this to run on the server. This is our way of talking to the server, right? So we're going to choose run on server. And we're going to make this reliable. And that means it will keep trying to send this RPC until the server has said, hey, I've got it. And then we can compile and we can set our logic in here. So let me get a text render in here. We're just going to say set text. And we're going to feed in the value that has been set. So we can just quickly make a value here if we want. So let me just... yeah, we should promote it to a variable, or maybe we would just make a literal text. Can you make text like this? Yeah, cool. And what we're going to say is just say that server interacted. Okay, we'll plug this in. And then all we need to do is call this function then here. So I'm going to drag off of this and call server interact. Let's go ahead and do that. Okay, cool. So what should happen now, if we go on the character to remind the flow, I press E on the client, it runs through, and then it goes into, calls this interact function on the thing that I've interacted with. So in this case, it would call this interact function on the client. And then what this is going to allow us to do is call our server RPC, and the server RPC is going to then run this code on the server. So it's going to set the value of that. Great. So let's start and see what happens when we've got this set up. Now, if we press play and I go over and try and do this, you can see that down in this log, just by here, we're getting this yellow message every time I try and do it. And the message we're getting is the UNet driver process remote function, no owning connection for actor. Function server interact will not be processed. Now, when we were learning about RPCs originally, you'll remember that RPCs from client to server can only be done via that connection between them. And if you remember, that connection is associated with the player controller. So you need to do it either on the controller itself or any actor that is owned by that player controller. Now, these are just placed in the level. These are not owned by a particular controller. And so therefore, they do not have the right to send a message, an RPC, to the server. So we need to change our approach here. We need to think, well, we need to run it from something that's owned from the player controller. Okay, we've got our character. Maybe we can forget about this logic here. And what we can do is set it up so instead of us doing the RPC from the ball itself, we can do it from the player instead. So we say, hey, server, I want to interact, rather than have the interactable say, hey, I've been interacted with. So we'll change our approach a little bit, the order in which we pass the responsibility over to the server. So that's where instead of calling this interact like this, we can go ahead, like I've got down in this bottom root, and we can call a server interact function instead. Now this is going to be, I've set this up already for us to save us some time, but if I jump to this, you can see this is set up as a reliable run on server again. So it's similar to our last setup. And what it does in here is it checks, okay, does the server think it can interact? And then it calls interact on that interactable. Now, a few things to discuss before we go a little further about this. So you can see that, first off, the server's checking, can it interact again? Even though, back over here, we already have checked, can they interact? Why do we do that? Now we do that because this is the client check-in, but the server is the one that decides everything for sure. And a client can, if they use cheats or hacks or whatever words you want to use for exploiting the memory on the local client, they can make their game be in a different state to what the server is. So they could force their game to say, hey, I'm allowed to interact with this thing, even if they're miles away from it, let's say. So it's always a good idea if we're then the client's asking for something, that when it gets to the server's time to perform that request, that they also do a little bit of check-in to make sure that this isn't a dubious request by a hacker. So that's why we do our can interact again. The second thing to consider here is we're passing pointers along here of the thing that has interacted with it and the thing the person or the character in this case interacted with. Now, these are pointers, but pointers that are, if it's a replicated actor, you're allowed to pass pointers across the network. Unreal does some clever stuff under the hood where when it replicates an actor, it's given a special ID, and that allows the server and the client to match up the objects in memory, because they're not going to be in the same position in memory on server and clients or between different clients, but they can be linked up using this special unique ID. So as long as the actor is replicated, you can send a pointer across the network and it'll be able to know which actor you're actually talking about, which is pretty cool. So let's now go into the interact function that we've got here and have a look what happens. So now that we're calling interact on the server, let's jump in. This is the logic that it's following. We're already on the server now, right? So we don't actually need to call the server interact here because, well, we're already on the server. So I can kind of let's just disconnect this and get rid of this for now. What we need to do, if we think about this, is the server's had that request now. So we could instead now let the server send out information to say, okay, we need all of you connected clients to update your text. So what we can do is we can make our server send a multicast out to all of the different clients that we've got. So let's go ahead and do this. First, we need to go ahead and make a multicast function then. So I'm going to go ahead here. Okay, we could maybe just go ahead and change this. It probably best if we're not. We'll just make it we'll call it a new custom event. And this is going to be multicast. And then we'll call it interact. Okay, and what we want this to do, we'll set it up so that it is a multicast. And then we're going to just basically do the same logic as that we had here. So let's go ahead and put this in. I'll tell you what, just to make sure we're not confused, we'll move this out of the way so we don't have to look at that old one anymore, because we're going to be going down this logic. So what we want to do then is as soon as the server has been saying, hey, I want to interact with this actor, we're then going to go ahead and call this multicast interact, and that will tell the server to send out this event to all connected clients, including itself. So let's see what happens then. So we'll press save and we'll see if any of this is working for us. And also one thing before we press that, let's go ahead and put in a breakpoint to see how often this gets hit. So we're pressing play. We're going to walk up to this and we're going to press the button. You can see we're getting a breakpoint here. You can see that we're up on the server by here. Okay, cool. And then I'm going to press continue. Okay, and we can see that it has changed. The text has changed for both as well. Now, that multicast actually did run more than once. I just need to set this to no debug. It was just debugging the server for me there, so apologies. Let's go ahead and run this again. So when I go up and press this, and it sends that multicast out, we press no debug actor selected. Now what we get, you can see on the client gets this function called on it. That's what the multicast does. It calls it on all clients that are relevant here. And then we'll press continue again, and you can see it's now on the second client. that is running that logic. So this logic happens on the server that called the multicast and any connecting clients to it as well. So there we go. We can now see that that server interacted has been replicated, and we've got that behavior sent out to all clients. So this isn't a replicated bit of text. Instead, we're reacting to something and sending an event out to everyone. Now, the slight problem we have with this is the following. So let's start the situation up again. But this time, we're going to get one of our players to go further away. So I am now outside of range of both the player and that blue ball, so it stopped moving. We'll talk about why it stopped moving in a moment. But if just for reference, if I go back in range, it'll keep moving and it catches up. Okay, and it's back in sync now. But what we're going to do then is get this this first player then to interact with it, and you can see, okay, I interact with it. We can probably turn off these breakpoints now. Let me remember to do that so we don't have it again. And when we interact with it now, you can see that this player over here, the text hasn't changed for those because they're outside of relevancy. And you think, oh, maybe like the movement when we go back in, it'll update. But no, it doesn't. Now, and that's the problem, or that can be a problem with RPCs. It can also be a great thing. Sometimes you want it to work this way. What happened is the server at one point in time got told, oh, I need to tell everyone about this. Everyone who's relevant. If you weren't relevant, you're not going to know about it. It's like FOMO, right? You're missing out on this. And when you come back in, no one's going to give you that information to catch you up. And so if it's gameplay critical, this would be quite a problematic situation. If this was a state of a door that had been opened, for one player it would look open and they can see through it. The other player, it's closed, they can't see through it. And the player who can see through it has an advantage if this is a shooter and the player's walking past it, for example. So if it's gameplay critical, you want to be considering, is a multicast going to be something that's suitable for this? So there is another approach that we can take, and that's going to be using replicated data with an on-rep as well. And we'll talk about that in a moment. But what we're going to first look at is a little bit about client prediction. So we talked about client prediction. I'm going to, a very quick summary of it would be, because in a multiplayer game we have latency, it means that when a client is giving input, if we're going to wait for that message to go to the server and the server then send out all the server authoritative response to that to everyone, we could be waiting a noticeable amount of time. We're not talking seconds, but enough to feel like the game isn't responsive. So client prediction gives you that chance to react locally so that the player feels like the game is snappy, but actually it's just a faking it locally and trying to predict what the server's going to do. Now, a lot of the time it will be right, because, you know, if I press shoot, I'm gonna the muzzle of my gun's gonna play a flash animation. It'll make a bang noise most of the time, right? Unless you're out of ammo, maybe. So you can predict that if the client has ammo and they're not on like a reload timer or anything like that, and they press shoot, it's fine for it to flash. That's almost always going to happen. The server's almost always going to let that happen. But let's say that somehow they're using some cheat where they're trying to make their gun locally have more ammo. So then when they try and shoot again, it'll go, it'll do the effect. And then the server's going to try and say, get this request saying, hey, they're trying to shoot. But the server's going to say they don't have any ammo. They're not allowed to shoot. And so it's not going to send out information to all the other connected clients saying this player has shot, you need to play a little fire effect. So as a result of that, one player is going to see the predicted end result, but all those who are connected are not going to see it, and it causes a bit of a disparity. So whilst we are improving the responsiveness and the snappiness of the kind of input, there are those situations you can get into where there's a disparity between what players are seeing as a result. And sometimes it's not just with cheats as well. It can happen naturally, and so it's something to kind of be aware of. So what we're going to do in the editor preferences, you can actually simulate lag. So if we look at network emulation settings here, just make sure my game is stopped. So yeah, this applies. And I can go ahead and say, okay, I want this latency to be, it's currently set to be a little bit bad. We can make it really bad if we want. So if I just go ahead and just say we've got 1,000, that's pretty much like a second of lag here, right? So what we're going to see now is when one player interacts with this. Okay, so I go up to it, and we'll both look at it at the same time. And when I press it, I pressed it, and then it takes a second to update. So you can see from my perspective as a player, I might start pressing E a bunch of times because it didn't seem like it reacted the first time, like it didn't work. And so that's why we kind of look for client prediction. So I'm going to press it now. And now finally it updates. So obviously I've upped the networking so you can kind of see that there's an obvious delay. I can set it back to bad now just so it's a little less horrible and we get less spams in the log saying that there's out of date movement information and the likes. But you can see why we'd want client prediction at least. So what we can try and do is predict that and make it for the client who's actually doing the interaction that it instantly kind of changes it for us instead. So let's have a little look at how we set that up then. So in our character, before we were doing our client only interact, and then we updated it so that it does an RPC to the server to interact instead. But what we could do actually is do both. So on the player that interacted with it, that pressed E, remember this is input processing, so only the client who did it is going to be getting this logic running on their machine. That means that we can go ahead and say, okay, let's do the client-side interact like we did before. No one else is going to know about that. But then what we'll do is we'll ask the server to do it too. And then the server will know about it and everyone else will eventually know about it too. So we can kind of do both of them in that way. And if we jump into the interact of our actor over here. So one thing we need to be aware of now is now that we're calling this on both server and client, we don't really want, the client can't do multicasts, right? It's only a server that can multicast out. So now we're going to have to kind of branch our logic based on, is this being called from the server or is this being called from the client? And like we did with our movement, it might be a good idea for us to say, okay, does it have authority? As a quick way to basically say standalone or dedicated server. So if so, we can go ahead and do this logic here. But if not, then let's just set the text locally anyway. And what I'll do to make it more obvious, typically you would set it to the same value, but just to demo how this works, what we'll do is I accidentally pressed the wrong button, apologies. Let me paste this in. If we are not a dedicated server, therefore with a client, what we're going to do is instantly set it, and I'll just say client interacted instead. Okay, so now when I go ahead and do this, let's observe how it reacts. So I'm going to go up to it. We're both looking at it. You can see that it went client interacted and then server interacted. Great. Okay, cool. Now, actually, we're noticing that it didn't actually call on the other client as well. Let's see why that was. But let's just double check, and so you can observe it happening here. So it says client interacted, server interacted. Oh, it has happened. Maybe I think I maybe walked out of relevancy or something. That might be why it happened. I'm not 100%. But yeah, so we can see that the result of this is we have that client prediction, and it's followed by the server updating it. So you'll see the player on the left will have client interacted briefly, then it's a server, and the player on the right, it won't have client predicted, it'll just get that server update a little bit later. So here we go one more time, and there we go. You can see the server's corrected it. So that's one way of us implementing. Okay, so we can see that our client prediction works, but let's have a little look at some little quirks of this as well to be aware of. So if I was to interact with this once and then I interact with it again, yeah, okay, so I can keep doing that. That's not too much of a problem. And the reason that is happening is because we are sending out a message to all of the connected clients when this happens. But do you remember the problem we had with using an RPC is that if this player is outside of relevancy and this player goes and interacts with it, they're not going to get those updates about it, right? So we're going to change our approach now to a replicated scenario where we're going to replicate the text out to clients, and then the clients can react to that replicated name changing, and then they can change their own text above the actor to match what the server wants them to have. So let's go and have a look about how we would go ahead and do that. So within our replicated actor, we're not going to go through that multicast approach now. We're going to have a replicated member instead. So let's add a new property. So within our variables, I'm going to just press the plus. I'm going to make this a, let's just make it a, let's make it a string. There's no harm making it a string. And then we're going to just call this the name. Okay. Now what we need to do in order to get this replicated is we need to, when I just get this compiled as well, so we have a default value. Let's just say default name, just so we can see if we're ever in a situation where it hasn't been set. But in order to set it as replicated, we need to use these properties here. So there we go. We've got replicated or rep notify. So what replicated does is it will update clients with this data when it changes. What rep notify does is the same, but look, when I click this now, over in this function list, we're going to get a new function show up. You can see we've got an onRep name. So what that means is when the server sends an update to this property to the client's then going to execute this function here. And we click on it and it just lets us do whatever we want as a response. So really we kind of want to do that logic that we had in here. We want to set the name on the client when it receives that. So when that data changes, we want to go and set the name on the clients who've received that information. So I'm just going to copy this. We're going to jump into our onRep. Oh, sorry, I thought I was trying to rename it. Nope. And we're just going to set the text here. And we're just going to say rept interacted, just so we get a different name to before to make sure that kind of logic is running here. Now, what we also need to do is tell this data to be set on the server. At the moment, we've still got a multicast set up, haven't we? So let's go into here. And let's flow through the logic to remind ourselves. So on the client, they interact, it does some client prediction here, and then it sends a interact server RPC here. So on the server, the player character then goes through and makes sure they can interact with it, and then they call on the server the interact function on the actor that we're trying to interact with. We open up this and we look at what happens when it interacts. If it's on the server, we go ahead and do a multicast. If it's on the client, we're going to do the client prediction. Okay, cool. So let's go ahead and swap this out. Instead of doing our multicast now, in order to get this to send out, all we need to do is change the data. Change the data and the server will send it out. That's the plan at least, right? So we get this value. When I drag this in, sorry, I should hold Alt when I drag it in. I'm going to go ahead and hook this up and I can set it to be what I want it to be. So here we're going to just say rept interaction, and you can see that the variable here says set with notify, so it's reminding you it's going to call that notify function. So oh yeah, that's a point. So when this is called, it's going to actually, it calls it on the server too. It'll perform this logic, which is different to C++. If you were doing an onRep in C++, when you set the value, it doesn't automatically call that onRep. So it's a little quirk between BP and CPP. But okay, so I call it on the server, it's going to run this function. So let's go ahead and open it. And we can see right now, actually, we're just manually setting the value. So we don't actually need to do that because we've already set the value, right? Just to go back, we set it here. So we can just read that value. We don't have to manually do it here. So let's go ahead and replace this like that. So now what we're saying is anytime it sets the value, can you please set the text? That'll do it on the server. And then when the client receives this, it will also run this logic as well. So if we just go back into this, this looks like it's probably going to work for me. We've got a client prediction here, but if it's on the server, it'll set a replicated value, which let's double check. I did set it as replicated, right? Brill. And then that's going to propagate down to the client via this onRep name function. Right, so let's see, does this work then? So we're going to jump in. And what we've got now is if I go and interact with this, we get a client prediction, but then we get rept interaction. And you can see, well, look at that. It's here, it's showing up for both of them. Great. So our replicated scenario works. But we have a couple of things to discuss here. First off, let's show how it is an improved scenario from one regard compared to running the RPC. Because now if we restart this, and we'll get one of the players far away, out of relevancy of this whole situation, over the other side of the map, collecting berries or something, right? And now we'll get this character, once they're out of relevancy, we're going to then interact with it, we know that they're not going to get that data now, right? Because it's not relevant. But when we come back into relevancy, what we found with the RPCs is we have no way of getting that information because we've missed it. It's a fire and forget sort of thing. But we can see when we come in, now we get that updated information. That's one of the great perks of replicated data, is the client will always get that data when they get relevant, if they weren't relevant when it was set originally. That's how the movement is done as well. That's why the movement updates to where it is immediately when you come into relevancy. So that's one perk that we've got here. The unfortunate thing though is actually if I was to interact with this again, it says client interacted, but oh, okay, it's now not repping out. So one of them, it says rep interaction, the other one just is stuck on the client prediction side of things. And why is that? Now, it comes down to how on rep works, or the rep notify. So despite us having this function, if you remember, the rule I said was that when this data is set on the server, it will replicate. It will send it to clients, and then the client, when it's set on the client, will run the on rep logic. However, there's one thing set where it doesn't do that if the data hasn't changed. So if you try and set the data to be the same value twice in a row, it's not going to keep sending that data to the clients. It's wasteful, right? Think of movement, for example. If you're standing still, do you need to send your location and rotation continually out over the network if they haven't moved? No. And you're going to save so much by not doing that. But as a result, you need to be aware of that in different scenarios where you might get unexpected behavior. So what's actually happening here is I have correctly interacted with it again, but when I actually try and observe the sorry, let me press play again. When I try and observe it getting repped for the second time, it doesn't happen because the server is being told, hey, set it to say repped interaction. As far as the server's concerned, that text value is repped interaction right now. And so it doesn't send out another update to the clients because it thinks, hey, the clients already know it's repped interaction. So this introduces the dangers of locally changing replicated data on clients. So by locally changing, what I mean is on a client, you're changing a replicated data, a piece of data. Because really, when it's replicated, what we're saying is the server will keep me in sync with the true value of this. And if we make that decision to change it ourselves, we're kind of breaking that rule, that contract that we've made, and therefore we can introduce these sort of scenarios. But then it's difficult when we want to do some client prediction and the likes. Well, you've kind of got to weigh up your choices of what you want to do, and you need to really work out the best way to deal those sort of scenarios. Okay, so that was us setting up an on-rep situation, and we can see hopefully the benefits of doing that is that that data will always get to the clients instead. So the other thing I want you to take away from that is that generally speaking, you want to avoid setting the data of replicated properties on the client. It typically causes problems. It's not a great practice to do because really the server has no way to know that the client has changed that, and as we've just seen, it can affect the on-rep functionality. It's also worth knowing that when you set that data on the client, it will still call that rep notify function and perform that logic again, and that might not be a problem, but it could cause unexpected behavior if you're not aware of that. Now, there is another thing that that same problem introduces. So the problem being that if the data hasn't changed, it's not going to send the information out. So let's look at our character here. So our character is, let's go into up here. Our character has a bit of logic right at the start where we sort out what color that they are. You'll notice that when I'm playing the game, I could even change it to 3 players and press start. You'll see that each one of these has a different color to them. We have a yellow, pink and green colors here. And so how that kind of bit of logic is sorted is within our player character, we set up a bit of input here, and then we assign something called a player index to clients. Now, we don't really need to worry about how I've gone ahead and done this, but effectively on the server, there's a list of the players, and I kind of get the server to work out in that list of players what index are they, so that they have a unique little number to identify them by, 0, 1 and 2, because in computer science we start counting from 0 instead of 1, forgive us. And then what I do is I set that on the character, so each character has its player index replicated out. So you can see this is a rep notify, just like we'd set up a moment ago. And then we've got a little bit of logic then, where in the on rep of this player index, we set up the material of the character, and we call this little function that will look up based on the player index. It looks at the material colors and say, if their index is 0, make them yellow. If their index is 1, make them green. If their index is 2, make them pink. Okay, so that works. That is the way that our characters kind of get their new color set in. However, when I first set it up, you encounter a problem. So let me just default this value back to 0, and I'll talk you through this. So what we can see in this situation is the players who forgot their colors, other than player, well, this player, the pink one's got their color. What about this one here? Okay, this character here, this happens to be the first player, even though it's spawned on the actually no, it's not the first player, it's the second client, but on the server it's the player in index 0. So we can see when they move, it's the yellow ring that's moving around, but they don't actually have the yellow color. They're actually just a gray kind of checkered default material. So why is that? Why is it something wrong, going wrong for this particular client? So the reason is down to that replication kind of consideration that I mentioned prior, that the on rep is only going to get set if the data has changed. So if we look at this character and we look at this player index value that I'd set up, this default value for any integer you make in the game will start as 0. Okay, that's the base default for you. So what's actually happening then is when the server runs the logic on the character, so if we go back to this where it says, okay, go and assign an index to it, it gets to this bit and it says, okay, for player, for the third player, we're going to give them index 2. For the second player, we're going to give them index 1. And for the first player, we're going to give them index 0. So it sets that. Now, the rule we have with notifies is it's only going to send that data out and call a rep notify if that data has changed. So the default value was 0. And as a result, that means that the as far as the server is concerned, it doesn't need to tell the first player about that change because its value is already 0. And so as a result, that means when the client is expecting this on rep to get called and set their color, it's not happening because the server didn't bother sending them an update because they're already 0. So the way I kind of solved this problem here was I just set a make sure that the default value isn't something that's getting used out by your system that's determining the coloring here. So I just set my default value to be -1, and that's means that, well, whenever we set the index to either 0, 1, 2, 3, 4, whatever, it's all going to be different from -1, so it's going to force that update to be sent out as well. So yeah, it's a little bit of a nuanced situation, but it actually comes up more often than you think. And it's something to really be aware of is that the replicated property and any associated on reps is only going to be sent out if that data is different. Now, as much as this is, you might think this is just affecting when you spawn, the reality is the begin play and the spawning of an actor doesn't only happen at the start of the game. Because if you remember, if I go out of relevancy of these pawns, how does it handle this in a dedicated server network game? Well, it destroys them. They're no longer relevant for me. And what happens when I go back into relevancy is it spawns them back in. And that will run the begin play logic of that actor again. And so as a result now, we're going to be re-sending out information. We're going to be rerunning the begin play script and all of that jazz. And so, yeah, this issue, that default value might actually come into it more than you think. Maybe at the start of your game, it's not the same value. But it might be something in gameplay where it ends up being changed to that default value, and when they come back into relevancy, actually the value that the server wants to send out to the client who's just come into relevancy, sorry, isn't different from the default value, so it's not going to go ahead and send that data. So yeah, that's another kind of situation to consider with this problem. So the final thing that we're going to have a little look at then is the concept of spawning actors at runtime, because these are what we'd call level actors. They're placed in the level at design time. That means the clients already know that they exist because the clients have all the same game files, remember. Now, if we're on a server instead and we spawn an actor, the client's not going to know about that unless we tell them. So I've set up a way for us to drop a little actor on the floor, but let's think about what's going to happen before we do it. So I could code it so that when I spawn something, let's just jump into the spawning logic. Let's jump into the event graph down here. I've got a logic in here for spawn a droppable. So when I press a certain bit of input up here, I call a function called spawn droppable, and then in here I can define my spawning logic, right? I can just call, for example, spawn actor like this. Now, I could just run this on the client. The problem is other clients in the server aren't going to know about it. I could just spawn it on the server, but the clients aren't going to know about this particular actor we're dropping unless it's a replicated actor. So we do have our droppable actor. Let me just plug this in over here so you can see it, and we can see we have set this as something that replicates already. Great. You notice I don't have replicate movement in because this actor doesn't move. We'll still know the location of where it is in the world. That gets set by default, but it's not going to have any movement updated after that because it doesn't move. Okay, cool. So let's go ahead and see it working, because we've set this as replicated. We're spawning it on the server. So if I press F now in the middle here, you can see I drop a block in, and now we can all see this block. Now, the nice thing about this then is just because I set it as replicated, that's enough for that actor to be spawned. Now, what happens when we go out of relevancy of this? So I'm going to move out of relevancy of this actor. Oh, actually, it's a larger error. It's this white line over here. Apologies. And what we see now is it's disappeared. Okay, cool. So unlike the level actors, any spawned actors at runtime are going to be destroyed when that connection is closed. When they're no longer relevant, we destroy it, and then it will spawn it again. So this is what is happening with our pawns. The pawns are spawned in. They're not actually in the game when we start. We have these spawn points, but that's not the pawn, right? So the pawns are actually spawned in, and that's why they behave in the same way there, which is worth being aware of. So how did we set that up? Let's go in here and we'll see. Okay, so when we interact, I call a function here called spawn droppable. Let's have a look at the setup of that. When I click on this, we can see this is a run on server. So it's a client interaction. I'm pressing F. We need to tell the server about that. It's a reliable run on server RPC. And then we have two things to consider here. There's two different approaches that we can spawn this. Now, I've done it by, I've got myself something called a spawnable manager. So that handles any spawning of spawnable actors in the game. I ask it, hey, can you spawn me an actor, please? It's as simple as that. And if we go and have a look at how that does that, it just calls the spawn actor function. There's nothing really to it. It's pretty straightforward. But the important thing is, what is responsible for spawning it? In this case, it's this spawnable manager. I can show you the spawnable manager. It's this little actor over here. And all I've set up on it is your ability to choose what is the actor that should be spawned. So I can set this as, I have two different types of one. I've got a spawnable actor, which is like an orange cone. So I'll change that. And what we'll see now is when I go ahead and spawn this, we'll now go ahead and get our little orange cone in instead. Great. And we can see that we've got a little number that's replicating out to all the connected clients as well. Now, as I said before, if we go out of relevancy of this, we should pretty much see that it disappears. Now, I'm going to spawn it in a different way. Let's go into a character, and instead of going through our spawnable manager, we're going to actually just spawn it directly from inside the character. Say, okay, the client asks us to, on the server, we're just going to go ahead and spawn it. Okay, similar logic to what we've got here. Now, we do pass in an owner, but if you leave this blank, it will be none. It'll treat the actor where it's called as the owner anyway, which would be this character, right? So let's see how this changes things. So now I'm going to spawn this, and then I'm going to run, out of relevancy. And okay, we can still see it. The players have gone. What about this player? If we run out of this, we can run over the same location as this character. We'll have a little look over. We can see the orange cone. Okay, so the orange cone. Oh no, the orange cone is gone. Okay, so this looks weird. Is this a bug? No, it's not a bug. Now, what is different between the scenarios is the owner of the actor when you spawn it. In this situation, the player who pressed E is the character that is spawning it, and thus the owner of this actor. And if you remember, the player is owned by the player controller, and the player controller is that very important class that allows server and client to communicate. So anything that's owned ultimately by the player controller will always be relevant for that player. So even if I'm outside of relevancy, I will always get updates about that. But as for the other characters that we had the pink character and the green character as well. They didn't spawn it, and so they're not going to get the always relevant kind of rule that the actor who placed it does. So that's something to be aware of as well, the ownership. And maybe we don't want that, because maybe that means if they're halfway across the whole world, they're still going to be getting updates about this actor, and that could be considered wasteful. So that's why in this situation, I put an alternative way of, hey, okay, let's make an actor that's responsible for the spawning of it. And that way, when we actually call spawn, the owner is going to be this actor that lives in the world. So that means that it's always going to be relevant to the spawnable manager, but not to the players. And so it'll be destroyed when the player goes out of relevancy, and we're not wasting time sending out updates then to them. So that hopefully gives us a bit of an overview of the main kind of things that we wanted to go over. It gives us an example of how actors behave relating to relevancy, how players react to each other, what we get for free out of the player character movement component, how anytime that there's input done on the client, no one is going to know about that unless you directly tell the server, because we work in a typically in a dedicated server environment. It's going to be a server authoritative model, where the server's the one who sets the state of the game. So the client can ask the server to do it, and then the server propagates it out to all connected clients to try and keep that synchronized world between all clients. We had a look at some of the kind of problems that we come across as we go as well, and that sometimes keeping in mind that the games on the clients and the server can be running the same code, and so you can actually have it look like the games are being in sync, even though there's nothing being sent across the network here. Like when we saw that this fake actor, when we're playing with this fake non-replicated actor here, that if I walk into this on all clients, if I stand right in it, so you can actually see a situation here where it hasn't stopped it on one of them. It finally has stopped it here now. So you can tell that it's glitchy this way. But what's happening here is because the movement of all the characters is emulated on every client, that code will run on every client, and so it will still stop it. But it's not synced up. This isn't replicated. But there are scenarios where that would be good enough behavior for you if it's not gameplay critical, that you don't need to send out from the server updates about everything. But if we want a proper replicated actor, then we need to set it up to be replicated. If we want the movement to be replicated, we need to flag it that we want the movement to be replicated. If you've made an actor replicated that was moving, you want to make sure that movement code's only running then on your server. You might want to try and do some client prediction to make it a little bit smoother, but be aware of some of the issues you have with client prediction, because if the server has data set and the client is changed that data, they're no longer going to be in sync, and it could affect a couple of issues with on-reps being fired like we saw earlier as well. We did see that there's different ways to send data out then. So the movement was kind of done automatically by ticking the replicates a movement section, but we then made a little interaction section where if I press E on this, we get a little bit of client prediction, and then we get that data repped out. And we looked at how that works if we were to do it with a multicast RPC, which is an event, and we looked at how to do it with a replicated property, which is more guaranteed data that will get sent to the client whenever they're relevant. And we learned that the RPCs are quick, but they are something that will be missed and gone forever if the player was not in range of that multicast RPC. And so if it's gameplay critical, it might not be the right tool for you to use. But we could pretty much simulate that by using a rep property and have a rep notify do the logic when that property gets sent out to other clients. So there's different ways to achieve the same thing, but you need to consider the pitfalls of either way when weighing up which one to use. The general advice is try and use replicated properties and rep notifies as a first port of call. And if there's problems with that, then you can look at using a RPC. Or if it's super critical in terms of timing, you might want to choose an RPC regardless, because RPCs are faster. And they also, unlike replicated properties, they're not as impacted by like a queue of data that's been needs to get sent out to all the clients, but there's a bit of a bottleneck perhaps. So they're more likely to get sent out sooner than any of these queued up replicated properties that need to be sent out to all of the clients. So there's definitely benefits of when to use them. And I guess it comes with experience then, and seeing the issues that come from either way of knowing which one is the best way to do it. Final thing I wanted to just mention is a interesting thing that I didn't consider when I was making this tutorial is actually the player location for this distance-based relevancy is based on the viewport of where like the camera is. That's where the player controller is. So because we're playing first person at the moment, I can pretty much, based on where my pawn is going to be the relevancy. So if I'm standing here, I know it's all good, and I'm outside of relevancy, I'll stop getting updates about things. However, if I was using a spring arm camera and I was in a third person perspective, do keep in mind that camera location isn't going to be where the character is. So my character could be inside of here, but my camera is outside of the area, and the things would then go out of relevancy even though it looks like I'm close enough to them that they shouldn't. Now, obviously in a real game you're not going to see these circles and notice those subtle things, but if you did have something with quite a small relevancy range of actors, it's something that you'd want to consider. But yeah, hopefully this has been useful anyway. Appreciate people checking out the video. It's a little bit more off the cuff this, so I know it's been a bit messier than the initial introduction of info, but I want to give people a chance to kind of see things in action in Unreal with some illustrated examples. But yeah, if you have any feedback, let me know. But thank you very much.